Who's got one here? You didn't do it. Who's got one that who wants to share? Come on. Yours, Mar? And I got yours shared, right? I think I got. So which one are we looking at here? 50 something? Which one should we look at?
That is very neat.
50 what? 51?
And that's very scattered.
It is scattered. It is scattered with it. Okay, so we're going to have story time, I think. I think we'll have story. This right here is 1,000 less than 2 times the amount invested at 4.5. What I really liked what you did first was you labeled your variables first. Label them, label them, label them. It's really, 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 really easy to get these wrong if you don't label your variables. So this would be y is equal to, right? And you just write it like that. Amount invested at 3%. I like that. Okay, keep going. So together, there's 2 accounts working here, right? Working on money. One of them's pumping out some interest, another one's pumping out some interest. But together, the amount they earn together turns out to be how much? 10.20. So keep going. The amount of money is getting put into 2 accounts between 4.5 and 3%. It's going to be an effective interest rate between somewhere in there, right? Like effective means what happens if you just put it into one account. That's what you see that a lot in truth in lending documents. There's one of the big problems with lending money in the United States. There's a lot of problems, but one of them is you go to the bank and you talk to me to say I want to get some money from you, and I say okay, you can do it with all these stipulations, and I make it look really nice. But is it as nice as I make it out to be? No. So there's actually laws, like truth in lending laws. When you get loans from banks, they have to give you essentially like a 1-page summary that very clearly states what the effective interest rate is. So we said 5%. Is 5% higher than what we're actually going to get? Yeah. So we know that $20,000 would get us 1,000. So is it going to be less than $20,000? Yeah. Logically, it seems like that's the case. So I really like what you did here. Say out loud, what does that represent, Mar?
4.5% interest as a decimal.
The amount earned in interest, right? Off of the 4.5%. Why didn't you just put 4.5 times x?
Well, because that would be wrong.
Yeah, okay, that would be wrong. But why would it be wrong? Yes.
Well, because you just want decimals because percentages.
Yeah, 4.5 and if you left it at 450%, exactly, Alex. Like that's big. That's what when you get an answer that blows up on you, it's usually because someone hasn't converted properly. Like most commonly, people would put like 0.45. That's not 4.5%. And then what's this right here? That's the amount you earn off of what? Earned off of
less than 1,000.
Of the 3% account is what I'm saying. That's the amount you earn off of the 3% account. And when you add them together, what do you get? 1020. So now we have an equation that we can solve. You just have to be careful about solving it. So take it step by step and just make sure you don't get lost in the decimals. You have 0.045x plus, let's distribute this. What's 2 times 0.03? 0.06x minus, what's 0.03 times 1,000? Anybody know? Oh, come on, you can do that in your head. 30. Good job. Yeah. So we can do this out. We end up with, we can add, what happens when we add this and this? What do you get? 0.105. It's 45 plus 60. What's 45 plus 60? 105 minus 30 equals 1,020. So then you get 0.105. I like putting parentheses around just to be clear. Equals 1,050. And x equals, therefore, what's x going to be? 1,050 divided by 0.105. Can you use your calculator to do this? Sure. Absolutely. It's also just going to be 10,000. Now, are we done? No, because it's asking for how much money in each account, right? One of the values is, so in one account, which account is x? X is the 4.5 one, right? Okay, so x is the 4.5. How do we find the other one? Well, we know that y is equal to 2x minus what? 2x minus 1,000? Oh, is it 1,000? Yeah. So y is going to be 20,000 minus 1,000, so it's 19,000. So we have how much? So this one right here, 19,000. This one right here is 10,000. So we knew we needed, if it was 5%, we needed $20,000, right? But we have less. So we knew we had to have more money, less percentage earned. So it better be more, but more than 20,000. I think I misspoke before. Because we have a lower percentage rate. Is everybody clear on what my mistake was before? I said it can't be more. No, it has to be greater than 20,000. So is this sound realistic? 10,001, 19,000, another based on what we thought of before? Yeah. And could you check this if you wanted to? Yeah, you can check it. We don't need to check it, but you could check it. You multiply each one by the percent earned and add them together, and hopefully you get one. So as you add, so you have this 4% solution. As you add the 10% solution, before you add the 10% solution to the 4% solution, the 4% solution is 4%, right? But then as you add the 10% solution, the concentration of acid, does it go up or down? It goes up because you're adding something that's more concentrated than 4%. So it starts at 4% and it keeps on growing, right? Keeps on growing. Could it ever get to 10%? No, because there's already some 4% in there. Can you get as close as you want to 10%? You can get infinitely close, but can you ever get there? No. So it's key that you realize it's starting at 4%. You keep on adding it in, 10%, 10%, 10%. So the overall percentage goes up, 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 up. You can never get to 10. But it will. Do you agree we'll get to 6 at some point?
Yes.
It will. Okay. So first of all, we're trying to figure out how many variables do we need? What are we trying to solve for? To answer this question, you would use the sentence, I would add. To answer this question, I would add baseball players to the pizza? No. I would add what? What unit am I trying to find here? Liters of. Find what? That's what you're answering first. Find what? Liters added of what?
Solution.
Which solution?
Pure acid, right?
No, it's not pure. Added of 10% solution.
How many liters?
Yes.
So you get
So
6%.
correct. But to answer this question, we need to find how many liters that is. So we need to label this first. So again, it's only one. We like to use which variable if we only have one?
X.
We love X. We love X. So X is going to be equal to the liters added of 10% solution. How do you figure out, if I said, here is a solution of acid right here. How do you figure out the percentage of acid in it? Not the system, but what math do you need to do? You need to know what percentage acid the solution is. You need to know two things. The overall amount of the stuff and what? The solution is acid and something else. Let's say water, okay? If you want to find the percentage, of acid in the solution, you need to know overall how much of the stuff you have, but then you also need to know, okay, if you want to know the batting average of a baseball player, you need to know the number of at-bats and the number of hits.
Yeah.
So if you want to know the percentage of acid in a solution, you need to know the overall volume and what?
How much solution is in it?
How much acid is in it.
Yeah.
So the percentage acid overall is equal to the liters of acid over what? Total
liquid.
Total volume, exactly,
Yeah.
right. Is the total volume of our new solution, is it going to be greater than 10 or less than 10? So the total volume of the new one, is it going to be less than 10 or greater than 10? Or sorry, what did it say? It said you have 10 liters. Yeah, it's going to be less than 10 or greater than 10. No, the new overall solution we're making.
Greater.
It's going to better be greater because we're adding to 10 liters, right?
But just a less percentage.
So
Solution.
if we add X liters to 10 liters, how many liters do we have?
Greater than 10.
Yes, exactly. How do you say that out loud? If I add X and 10, 10 plus X. So we know the total volume is 10 plus X. Do you agree with that? Okay, the overall total volume. So we're almost there. We're almost there. Liters of acid. How many liters of acid are already in there?
10.
No, that's how many. That's the total volume already of the solution. That's not of acid. That's the total volume of what you have in there already. 4% of how much? 4% of how much?
10 liters.
4% of 10 liters is how much acid is in there, right? So that's 0.04 times what? Times 10. Correct. But we'll leave it like that for now. So this right here represents liters of acid already there. But what are we adding to that? We're adding more acid in, right? What's the concentrate? How much acid are we adding in? And how do we get this? That's the concentration, 0.04, and the 10 is the number of liters. How many liters of the new solution are we adding in?
That represents how much.
Wait. Let me finish this first. How many liters of the new solution are we adding in? X. So if we wanted to know how much acid we're adding in, you have to multiply x times what?
What we already have.
No, what's the new concentration? How did we get this right here?
For already knowing what we already have.
Correct.
Acid in
But what are those two? Correct. Exactly. So this is just 0.10 times x. So this right here represents the liters of acid added. So if we add the liters of acid that are already there, plus the liters of acid that we're adding in, we add them together, we end up with the liters of acid overall in our new solution. Is that what we wanted? Yes. But what do we want the overall percentage to be? 2%? I think it's supposed to be 6%. Yeah, oh, I didn't hear you right. Sorry. It's supposed to be 6%. So let's just clean this up a little bit. We now know 0.04 times 10 plus 0.10 times x all over 10 plus x. What does that have to equal? We want 0 point what? 0.06. How many variables do you have in this expression right here? 1. How many equations do you have? 1. So theoretically, can you solve for x? Do you hope that this is a contradiction, an identity, or a conditional statement? Which one do you hope it is? Identity would mean have an infinite number of solutions.
Contradiction.
Contradiction means it has no solutions. Conditional. You want it to be conditional. You want an answer to this, right? You want an answer. So try solving that right now. Try solving it. What do you do first? What should I multiply both sides by, kids? Nope. Not just 10. 10 what? 10 plus x. Please multiply both sides by 10 plus x. Because if you do that, what happens to the denominator on the left? It goes away. So you end up with, what's 0.4 times 10? Oh, sorry, 0.4. So you end up with 0.4 plus 0.1x is equal to 0.06 times 10 plus x. Keep going. Why would you multiply this by 100 right now? 40 plus 10x equals 6 times 10 plus x. You could, right? Yeah, it does get bigger. 0.4 plus 0.1x equals, what does it turn into? 0.6 plus 0.06x? Like that? Yeah, I like this. Is that right so far? How am I doing? I'm doing okay?
Yeah.
So if I subtract and subtract, I think I get something like 0.04x is equal to 0.2, something like that.
Yes.
So x is equal to 0.2 over 0.04, which is equal to 20 over 4, which is 5. So 5 what? This means 5 what? 5 liters. Is that an answer that kind of makes sense?
Yes.
Yeah, kind of makes sense. Good. Write as much down as you can. Don't skip steps. Be careful. Draw pictures. Don't try to do everything at once. There's a lot of things swirling out there that you have to be careful of, but you just have to practice and you have to make sure you notarize everything. So read the problem. This is from yesterday. Assign a variable to represent what you're trying to discover. Write an equation. Solve the equation. State the answer, and then check your answer. So I would like you to work on this one problem. I'll make some. You did this. I saw a lot of really good work. The first thing you need to do is make sure you say, ready, x is going to be number of what? Yeah, so some of you use different labels. Y is number of? Spell that right? Yeah, Nichols. And K-E-L-S, right? Okay, kids. There you go. Nice. So first thing you know is that x plus y has to be equal to 25. Value of x quarters. What is the value of x quarters? What's the value of x quarters? Yeah? 0.25 times what? Times, we see x. We used x up here. You can use it. So what's the value of y nickels? What's the value of y nickels? 0.05 times y. Exactly. So what happens when you add together the values of quarters and the value of nickels? You end up with the whole value. Do they tell you how much it should be? $5.65. So what do you now have? 0.25 x plus 0.05 y is equal to 5.65. Now, if I just said 25x and 5y equals 5.65, what would the problem have been?
Like 565.
You have to change it to 565, exactly. So if you're dealing with dollars on one side, you better be dealing with dollars on the other side. If you're dealing with cents on one side, you better be dealing with cents on the other. Now, Milo pointed out something by accident. What kind of answer should you get to this? X and Y should both be what type of number? Whole numbers. They better be whole numbers, right? Because it's not impossible, but I think it's not legal tender to chop quarters in half. And also, it's really hard to do. So theoretically, at this point, how do you solve this? How many equations do you have?
2.
Yeah, you have two variables and two equations. You have 1 and 2. What does y equal right there?
25 minus x.
Yeah, so what can you do with that 25 minus x? You can take this and plug it in right there. So you get 0.25x plus 0.05 times 25 minus x is equal to 5.65. So an additional point in your homework is finish this. We're not done yet, but I want to move on. So you're going to finish this. Because at this point, have we done the transfer to algebra phase? Yeah. Now it's just solving. The new thing with word problems is setting up to the point where we solve. Have you practiced solving these types of equations a bunch? The new stuff is what we've just done. So we're going to pause there, and you can part of your homework is we finish this. And what else is online? What I'd like you to do, we have a few minutes left, with your partner, I'd like you to start talking about this question.